Hello friends, today I have made a simple yet very useful water tank alarm system. This alarm alerts you as soon as the water tank gets full so no water gets wasted. The moment the wire comes in contact with water, our circuit will automatically activate the light. But I've chosen to use a charger or even a 9V battery because it's more reliable and saves the hassle of changing batteries again and again. The charger's connection is quite simple. Connect the charger's negative and the positive plus wire to the positive terminal. Be careful with the polarity. A wrong connection can damage your circuit. Now let's talk about testing. We tested this circuit inside a water-filled tank. As soon as the sensing wires come in contact with the water, the LED light turns on immediately. This indicates that the water has reached that specific level. As the water level continues to rise, more wires get activated, and the corresponding lights turn on one by one. Finally, when the tank is completely full, a buzzer or alarm goes off, giving us a clear warning that the water is about to overflow. It's a simple yet highly effective system for water tank monitoring. The circuit is working perfectly. Now let's take a look at how it's made. I took help from a professional PCB manufacturing website, JLCPCB.com. If you're into electronics or DIY circuit making, this platform is honestly a game changer. You can upload your PCB design directly to their website, and they'll manufacture it with extremely high precision. Even beginners can get their circuits made like a pro without any hassle. I've personally ordered multiple PCBs from them, and every single time the quality has been outstanding. Neat finish, accurate solder mask, and fast delivery right at my doorstep. If you're planning to turn your ideas into real working circuits, JLCPCB is the way to go. I've added the link in the description below. Make sure to visit once and try it out for yourself. To make this circuit, a BC547 transistor has been used, and I have used 5 transistors in it. I have installed them. Now let's start placing the components on the PCB. Everything is clearly printed on the PCB itself. Just follow the layout markings and you'll know exactly where each component goes and in which direction it should be installed. For this project, I've used 5 resistors. Each one is 1K ohm with a 1/4 watt. These resistors are small but play an important role in current control, so make sure they are firmly soldered in the right spots. Once the resistors are in place, we'll move on to the LED section. I've used 5 colorful LEDs here to give the project a vibrant and interactive look. These LEDs not only enhance the appearance, but also indicate the circuit's working status. Let's quickly mount them on the PCB and complete this part of the build. I quickly fixed all the LEDs in their proper positions on the board. This part is pretty simple if you place everything carefully. After that, I took a 5-volt buzzer and placed it in its designated spot. Next, I used a small wire connector to organize the wiring neatly. This not only keeps the circuit clean, but also helps in easy testing and replacement in the future. Once all the components were placed properly, I moved on to the soldering process. I carefully soldered all the joints to make sure the connections are strong and there's no risk of short circuits. Now we need to complete the connections for the water level indicator, WU, which are located at the bottom side of the board. Once all the connections are properly done, the indicator will give a signal as soon as the water inside the tank touches the sensor wires. For this purpose, I've used 6 jumper wires. Each wire will act as a sensor at a different water level point inside the tank. These wires will detect the water and send the signal to the circuit to activate the indicator. So let's go ahead and carefully place and connect each jumper wire into the circuit one by one, making sure the connections are secure and properly positioned for accurate detection. So friends, I have now connected all the jumper wires properly to the circuit. Each wire is neatly placed just below its corresponding LED, allowing us to monitor every water level stage clearly. That's all for today's video. I'll see you in the next one. Till then, take care, stay creative, and subscribe my channel.